Welcome to Python Basics with EJD. In this video, we begin to look at Python variable data types. Okay, we've had some introduction to variable data types and data structures in the third video, I think, where we talked about naming Python variables and we looked at some rules for naming variables in Python. And not to forget, our environment for writing, our environment is actually Google Colab this time around instead of Jupyter Notebook. So, and all you need to access that is to have a Gmail account. If you don't have one, you can easily make a Gmail account and then you get going. Okay, so now we are dealing with the sixth video, the sixth lesson, which is about Python variable data types. Okay, so for Python variable data types now, is this what I've opened? Yeah, it's open here now. Great. So yeah, we're talking about Python variable data types. So previously I told you that we have different types of variables for representing things in Python. We talked about variable data types and variable data structures. So here we're focusing on variable data types. And straight off, there are 5 common variable data types in Python. We have integers, we have floating point numbers, complex numbers, booleans, and strings. What are these ones? We've seen them before, but then we are going a bit deeper into them. So talking about integers, right? If you did maths, at least in high school or something like that, you will understand that integers are whole numbers, either negative or positive. So integers are used to store whole numbers without decimal points. So the key thing here is no decimal points, then you have integer. For instance, if you look at this cell now, I have x is equal to 5, y is equal to -3. Now, how do you check the variable type a particular variable is? Interestingly, because of the advantage of AI with Google Colab, you can actually point at it. You can point at your variable directly, like in this case. Yeah, okay. Is that not working here? Okay, I think that's not working. Interesting. Okay, good. So x is 5, y is equal to -3. And then you can use the type open and close bracket to check the variable type. So for instance, what is the type x? X is equal to 5 now. What is the type of x? So if you check using type, it tells you x is an integer. Okay, what's happening? Okay, too many sessions. So we can manage the sessions. So okay, we can manage the sessions and close any sessions we are not interested in. So we are using session 7 now. 6, yeah. So we can terminate all these ones. So terminate. Okay, done. So we can close. Yeah. So that's managing our memory. It's online, so we want to manage resources as much as possible. Okay, so if you like, so want to check the type x is equal to 5. So what type of variable is that? So you use type x in line 6. If you run that, so this tells you it's running. And once it's done, it tells you the type, and the type is integer. All right, that's integer. Then here we still have y equals -3. All right, so this is 5, just that, and y is -3. So you want to check the type y is again, just run again, and it also tells us it's integer. Now there's this debate. There's this debate about whether 0 is an integer or not. So let me just write a comment there. Is 0 an integer? That's the question. So in case you've been confused about whether 0 is an integer or not, so we have come to the final showdown right now. Is 0 an integer? So how do we settle that? We say z is equal to 0. So we assign 0 to z, right? So z is the variable, 0 is the number we're assigning to it. So if z is equal to 0, so anywhere you go now, z is seen as 0. So we want to check the type that z is now. So type of z, it's integer. Great. So 0 is actually an integer. So an integer is any number, any whole number, negative or positive, and also 0. Okay, those are integers. So every whole number that is negative or positive and also 0, then also 0, including 0, is an integer. Okay, so that's about integers. Now let's talk about floating point numbers. Floating point numbers are used to store decimal numbers. So interestingly, if you say x now is 3.14, y is minus 2.5. Now, one thing about Python is that I've been using XYZ. Normally, any new x I use will automatically, the x I've had so far is x equals 5. So by the time I come here and say x is equal to 3.14, so whatever x is here overwrites the previous x, interestingly. So x is equal to 3.14, override the previous x. And because this one, and so for floating point numbers now, this decimal you have here automatically makes it a float number. So, okay, yeah, this is what I was trying to do before. If you point at x so far, because we have not run this, it's still showing integer that x is 5. But now we are going to reassign it here and then we can know. So if I go back there now, those values are reassigned. So if I point at this, okay, this is still not answering. Okay. All right, let's just keep going. Okay, so 3.14, you have decimal numbers, right? Integers don't have decimals for sure. So y is minus 2.5, of course, because of the point of this decimal point, then it's also floating. Now, interestingly, z is 5.0, right? Once you add, normally 5 is supposed to be an integer, but once you say 0.0, it automatically becomes a float. Don't forget the other time when we checked 5, which was x, it was said to be an integer. Let's see here. So we check for x first, which is 3.14. It says it's float. What about y, which is minus 2.5? It says it is float also. What about z, which is 5? I mean, basically 5, but then we say 5.0. It automatically becomes float too because we've added decimal point to it. Okay? So far we have seen two variable data types. Those are integers and floating point numbers. Next, we are going to see complex numbers. Complex numbers. Now, I always like to give this illustration. At least in my experience, right? When we're in elementary school, that's primary school. Anytime we have to subtract, like say 3 minus 2, that was 1. But whenever we had 2 minus 3, that was impossible at elementary school. So 2 minus 3, you couldn't remove 3 from 2 at elementary school back in the days. I don't know if that's still the standard now, But then we got to junior high school. In junior high, we got to junior high school and we discovered, oh, we could actually remove 3 from 2 using the number line. So all you just need to do is draw your number line with 0 at the center, 1, 2, 3, 4, 5, 6 to the right, minus 1, minus 2, minus 3, minus 4 to the left. Then start from 2 and move 3 steps backwards. So if you start from 2 and move 3 steps backwards, you get your answer to be minus 1. Because from 2, 3 steps backward, you move to 1, you move to 0, second step, then you move third step to minus 1. So we discovered that junior high school, that 2 minus 3 was minus 1. And then we got to senior high school, yes. And there we discovered that we could find the square root of 4, we could find the square root of 16 and things like that. But we couldn't find the square root of minus 4. We could find the square root of 1, but we couldn't find the square root of minus 1. And so anytime we saw anything like that in secondary school, we'll say impossible and we'll move on. And then I studied math in the university, and then we got to that point where we were told that the square root of a negative of minus 1 is j or I, depending on whether you're a physicist or an electrical engineer or whatever it is you are. All right. So we saw that, the square root of negative could actually be possible to the point that the square root of minus 1 will now be the square root of minus 4 rather will be square root of minus 1 times square root of 4. So square root of 4 is 2, square root of minus 1 is j. So square root of 4 minus 4 will then be 2j. So that's why we have the idea of complex numbers. So in Python, a complex is a built-in data type that represents a complex number with a real and imaginary part. Complex numbers are used in mathematical operations involving imaginary quantities and represented in Python using the j. You can use small j or capital J as you like. So using that suffix to indicate the imaginary part, it should, okay, it should be known that, I think, okay, let me say, I think it should be understood, it should be understood. That's me working on the text now like we did previously. Okay, I just click on this. It should be understood that j is also, small j is capital J is the same thing as square root of minus 1. That's the whole essence of complex numbers. Generally speaking, a complex number is of the form z equals x plus yj, So where X is the real part and Y is the imaginary part. So people in math, science, math, physics, chemistry, maybe engineering would understand this whole idea. So to create a complex variable in Python, you can use the complex function and pass in the real and imaginary parts as arguments. So of course, I'm talking about these variable data types. After this, now we'll now begin to look at, we've looked at integers and floats. So we're going to look at arithmetic operations in general, because we are going to look at that as a whole video on its own. Then after that, I think we'll be looking at complex number operations. So these are just some kind of introduction to these variable types. Okay. So to create a complex, so imagine you want to create a complex number here. You just say my complex is equal to complex 1, 2. So what this is will give is 1 plus 2j if you print it. So if you print this now, it gives us 1 plus 2j. All right. So in this example, my complex is the variable name. So this my complex is the variable name. So if you use this complex directly, it wouldn't be a correct variable name to give us an error. Oh, it's still not, it's giving a hand. It's supposed to give us an error because complex is a standard Python word. So, but if I say my complex, then it automatically changes it. So, and things can now work well in this case. Okay, my complex. Yeah, what's wrong here? Complex is not callable. Should be. Okay, let's go back. This should be fine. Okay. Oh, let me just go back to what it was. Okay. Okay, what's happening here? Interesting. It just worked now. Okay, let's rerun from the beginning. Let me clear all outputs. Sometimes we have times like that, right? So let me just run this again. This, 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 floats. All these are floats. Then we come to complex now. Okay, it's still giving that error, really. Okay, let me just call it my C. My C, and then I call it my C. My C. Okay, and then I run that. Okay. I wonder what's wrong here though. But it's just worked not quite long. Okay, maybe I should, let me take it back to what it was originally and just remove it and start afresh. Let's see if that helps anything. So back to Google Colab, lesson 6 it is. Lesson 6. Yeah, Python variable data types, that's what we're considering, Yeah, so I expand this. So again, don't be carried away that you have an output here. So you have to start afresh as much as possible, especially if what you're doing, if they are linked together. Or better still, let me clear all the outputs. Okay, I think that's better. Then clear outputs. Or let me do restart session. Let me restart the session and just say yes to that. Yeah, so I restart the session so it can start afresh. Okay, so I run this. Okay, then I run this. I run this. I run this. 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 Then for complex numbers, I think we should be good. Yeah, it works now. I wonder what was the issue before. Okay, so here we see that in this example, my complex is the variable name, and 1 and 2 are the real and imaginary part. So this 1 is the real part. The 2 is the imaginary part because it's attached to J of the complex number respectively. You can perform various mathematical operations on complex numbers values such as addition, subtraction, multiplication, and division using arithmetic operations like plus, minus, times, and divide. So we're going to do a whole video on complex number operations subsequently. So watch out for that. So here now, if I say X is complex 1, 2, Y is complex 3, 3, 4. So, complex 1 will give us 1 plus 2J, just like we saw before. And complex 3, 4 will give us 3 plus 4J. So Z equals X plus Y will be, so you add 1 plus, the real to real 1 plus 3, that's 4. Complex to complex, 2 plus 4, that's 6. So if you print this now, you get 4 plus 6j, for adding those two complex numbers together. You can also access the real and imaginary parts of a complex number using the real and imag attributes. All right. So, you can make complex numbers by just writing them out. Also, I think we're going to see that later. So you can also access the imaginary part. So if you have my complex is 1, 2, my complex 2, 3 minus 5, my complex 3 is the addition of this to that. 1 plus 3 is 4, 2 minus 5 is minus 3, so like that. So you can so you can print my complex 3, and then you can, to get the real part, just say my complex 3 dot the real, gives you the real part. Then you can have my imaginary part, my complex 3 dot imag, gives you the imaginary part. Then you can print the real part and the imaginary part, and then, this way. So my complex 3 is actually, when you add 1 plus 3, 4, 2 minus 3, minus 5, that's minus 3. So you have minus 4 minus 3j. So the real part now, you extract that, by saying my complex 3 dot real. So it extracts the real part. So the real part is 4.0. The imaginary part will be minus 3.0. So you can see we are using F string here this time around. Okay. So in line 10, we are using F string, but here we are using regular print, because we are not using F string, but if you're using F string, it has to be in this brace. So you can retrieve imaginary and complex part and real part like that. So in addition to that, right, Python provides some built-in functions for working with complex numbers, such as absolute, ABS for calculating the absolute value or magnitude of a complex number, and conjugate for calculating the conjugate of a complex number. That is what negates the imaginary part. So for instance, self-written complex number. So apart from using complex to call real number to call complex numbers, you can actually write it directly, right? So self-written complex number without the complex keyword are possible. For instance, like you say A is 3 plus 4j. So the absolute value of A now will be abs A. So that'll be square root of 3 squared plus 4 squared, and that'll be 5, right? Then you can print that here. Then you can also get the conjugate 3 plus 4j. The conjugate, of course, you expect it to be 3 minus 4j. Just change the sign. So you run this and you get it. So we're going to still do a video to look at these things in depth. Now we have booleans too as variable data types in Python. So booleans are used in programming to make logical decisions and control the flow of program execution. They are used to store values that are either true or false. So Boolean variables are basically true or false, basically. So that's why I have this very short thing. So, but we're going to also have a whole video to do different Boolean operations. So watch out also. So if you say X is true and Y is false, you want to check the type that X is, because true is assigned to it. So it sees it as Boolean, right? Y is also seen as Boolean because it is false is assigned to it. And lastly, the last variable we'll be looking at is what we call the strings variable. Of course, we are going to have string operations, a whole video on string operations. So watch out. So strings are used to store sequences of characters. I mean, we've used strings a lot. When we do printing and everything, under printing, we use strings a whole lot, right? So now we're really delving into the whole idea of strings. So strings are used to store sequences of characters. They are enclosed within single quotes, double quotes, or triple quotes. So you can make string by using single quote, double quotes, or triple quotes. But don't forget, when you're making multi-line comments, you need triple quotes. So strings are a fundamental data type in Python and are used to represent text data. Okay, I think I can split this up so that this can be on its own. Okay, so we have more space. So this comes down. So we have this. So now, yeah, we have this now. So strings are fundamental data type in Python and are used to represent text data. To create a string in Python, simply enclose a sequence of characters in single quotes, double quotes, or triple quotes. For instance, now I say string 1, hello world. Okay, maybe I should split this up so that we can see them one after the other. Okay, I'll just break this up. So in this case, I need to create more text cells. So I have this. Oh, okay, no, it should be code. Let me delete this. Yeah, it should be code, not text. So I have this. Then I copy this out. Then another code. I put this, copy this out. So for easier understanding, I think. So I copy this now. But no, not to worry, I'll expand this once I start explaining. All right. Then I have this also. So code, I put this here. Of course, we now have, I used all these blank prints to create space between them because I was doing everything together. But now that we are doing this, we can just remove all of this. So here, okay, let me just go. We'll put this still string 2. That's all we need here. So this string 3, this goes string. Now we have string 4 here. Then string 5. Good. So here now we're talking about strings. So you can see for this different strings, string 1, string 2. So this one has single quote, this one has double quote, this one has triple quote. Anyhow you do it, you're good. All right. So imagine for string 1, now you just say hello world, then print string 1. So once it turns red like this, then it's a string containing text or what you can call characters. Then if you use double quotes too, it's fine. It also works well. Same hello world. No, the result is the same. Then you can even use 3 quotes, still the same thing. Now, this cell is telling you that even a number, normally 4 is supposed to be a number, an integer. But once you put quotation mark on it, it automatically becomes a string, right? For instance, you can check. So you have 4, right? Let me create a new cell down to check. So first of all, we can print this, right? You just print. Now, this 4 now is not a number, it's actually a string. So how do you know that it is like that? So you can check the type. So you say type string 4. What type is string 4? So 4 is supposed to be a number, right? But because you have put it in quotation mark, it automatically becomes a string. So you can see it, though it is showing like a number, but it's actually a string. It's just like what happens in Excel, where a number can be showing as a text or something like that. Now for string 5s too, maybe I can have more words like I'm a great man, and I print that I have this. Now, this last line, is it a string or not? Well, if you ask me, it is not a string because we have not assigned it to any variable name, right? So the best it can be here is actually a comment, right? So if you run it, you're just going to see something, so you can see it is in quotation. It's not like everyone that is coming out normally, right? So it is just a comment. So, but once you assign a variable to it, like you say x is equal to that, and then you can now print that x. So if you print that x now, okay, let me even leave this alone, right? And just copy this out the way it is. So you can see it is still in quotation, so it's not a string per se. So let me do this code now. Then let me even say string 6. So if I say string 6 now is equal to that thing, all right? And then I print string 6, print string 6, okay? Like that. So of course, I can just run this and it gives me hello world. So you see the difference between this and this now. This is a comment, more like we use multi-line comment quotation for it. And since it's not assigned to a variable, then it is just a comment, it is not a string. But once it is assigned to a variable name, then it can become a string. So when you print it, it doesn't have this quotation you have right here. So that's the idea about Python variable data types. Interesting. So in the next set of videos now, I'll still be talking about Python variable data types, but then I'll be talking about arithmetic operations. For instance, I'll be talking about arithmetic operations, complex number operations, Boolean operations, and of course, string operations to really explain in depth what the possibilities are with these kind of things. So thank you for listening thus far. This is the end of this video. Let me know how helpful this is for you, and if there's something you're like going to try out, feel very free to let me know. If you have not subscribed, of course, you'll be missing a lot. So go ahead, subscribe, and hit the notification bell so you can always get alerted each time a new video is released. You can become a member of my channel by clicking join, and you can, we can interact. I can give you my math notes in PDF format depending on your level of membership and things like that. Of course, the codes to this playlist are available. Just check the description box in Python or in YouTube, on YouTube or on Facebook. Go to Google Drive, then you can download. If I advise that you download first and then you can follow step by step till I come your way again. Keep doing Python right. Bye.